Hello grade 10s and welcome back to another video with me, Miss Martins. In today's video we're going to look at algebra exam past paper questions. You'll see that we'll be going through factorizing, simplifying and solving, including inequalities and then also simultaneous. You don't want to miss any part of the video. I give teacher tips along the way. I do have other parts to this video where I go through other exam question papers, so check out the links in the description box below. Let's jump right into this question. The first question says factorize. Now, when you see the word factorize the following expressions fully, your brain must immediately go to the following types of factorizing that we learned about. Highest common factor, which is number one on the list for a reason. It's the most important type of factorizing. We must always look to see if we can take out our highest common factor first. Included in highest common factor, we have common bracket. So if you have a bracket that is in all the terms, we can take the bracket out. The bracket becomes the highest common factor. And we have grouping, where we literally group different terms together. And it's generally when there's more than 3 terms, but not always. Then we have dots, what I call dots. It's a shortened version of difference of 2 squares, or shortened word. So that's if we have 2 terms, a minus in between, square numbers, and even exponents. Then we've got trinomials when we have 3 terms. Just be careful, because you could have trinomials where we have a coefficient of the squared term. Then we have to do the more difficult trinomials, or maybe we can take it out as a highest common factor and then just normal straightforward trinomials, and then sum and difference of 2 cubes. Okay, so that would be cube numbers and so on. Right, let's see what we've got going over here. So number 1.1.1, I'm going to write it a bit bigger so you can see it. We've got x squared minus x. So I've got 2 terms. Remember, always try a highest common factor first. That is the rule. Can I take out a highest common factor? Yes, I can. This is x squared minus x. Both terms have x in it. So the rule is you take out the x with the lowest exponent. In other words, that's x to the power of 2. That's x to the power of 1. We take out x. Left over bracket. What are we left over with? Well, now how we do this is we say, and now there's 2 ways that I kind of do this with my class, is we either take the first term, x squared, divided it by x. So what's x squared divided by x? You're left with x. Another way to think about it, which sometimes this helps some of my students, it's easier for them to think of it like this. Think, what must I multiply x by? What must this be? To get x squared. And when I ask it like that, my students often say, oh yeah, I get what you're saying, ma'am. X times x is x squared. Okay, so that's the first term. Now, because we have 2 terms here, we're going to have 2 terms inside what I call the leftover bracket. So how do I get the second term? Well, x times what will give me negative x? Negative 1. Or you can say negative x divided by x. Negative x divided by x, those cancel out, leaving you with negative 1. That's where those 2 terms come from inside the bracket. And we're done. We fully factorized 1.1.1. Now, if we take a look at 1.1.2, first things first, always try highest common factor. But in this case, we have 4 terms, 1, 2, 3, 4. And if you look at each of the terms, it might be tempting to try and take out an x, because this term has an x, that term has an x, that term has an x, but this one does not have an x. So we can't take out an x. We can't take out an m. We can't take out a p, because all of the terms must have it in it. So we can't do that. We also can't take out a number. This is a 3 and this is a 3, but this is a 2 and a 2. So we cannot do highest common factor. And because we have more than 3 terms, it is going to be grouping. So this is where we group certain different terms together. So if you take a look at what we have, I'm going to be grouping the first 2 together and then the last 2 together. Generally, the rule, not the rule, but something that could help you is try and group the first 2 together and the last 2 and see if it works. If it doesn't, you might have to shuffle your expression around and try and group other terms together. But what I've got, let me write it a bit bigger for you, is this. What I'm going to do is I'm going to look at these 2 terms, group them together in my mind, and ask myself, can I take out a highest common factor from those 2 terms? So ignore the last 2 for now. Look at the first 2. Yes, I can. There's a 3 in both of them, so I can take out a 3. There's also, both of the first two terms have an x in them. So remember the rule, take out the x with the lowest exponent, so we're going to take out x. Open up your first leftover bracket. 3x squared divided by 3x leaves me with x. Or you can ask yourself, what must I multiply 3x by to get 3x squared? And the answer is x. 3x times x is 3x squared. Then we do the same thing, but with this term over here. So 3px divided by 3x, we're left with p. Just check to see if the signs also make sense. So 3x times positive x is 3x squared. 3x times p is positive 3px. That makes sense. Always distribute out to check if you factorize correctly. So now what I've done is I have done my first grouping and I've taken out a highest common factor from them. Now we're going to do it again, but we're going to do it with the last two terms. So they both have a minus 2 in them. So I'm going to take out a minus 2. They also both have an m in them. So I'm going to take out an m. Open up your leftover bracket. What is negative 2mx divided by negative 2m? You're left with x. Multiply it back in to check to see if it's correct, and it is. Then negative 2mp divided by negative 2m, we're left with positive p. Now just double check your signs. You can see how I hesitated now when I did the signs, because you have to think, you have to check. You can't just blindly write a positive or a negative. It has to make sense when you multiply it back in. So what I mean is, if you say negative 2m times positive x, you get negative 2mx, which is what we want. If you say negative 2m times positive p, we get negative 2mp, which is what we want. If we accidentally put a negative here, then a negative times a negative would be a positive, but you see that this is not a positive. So this can't be, this has to be a positive. Okay, now we're not done. Take a look at what we've done now. What we have now is no longer 4 terms, we have 2 terms. There's my first term, and there's my second term. Remember, terms are separated by pluses and minuses, so this is what separates the terms. Inside brackets, we don't count that. So this entire first yellow piece is one term, and then another term. Do they have anything in common that I can take out? Yes, they do. Take a look very carefully. This bracket, x plus p, is the same as this bracket, x plus p. They have the same brackets. They have what I call a common bracket. It's kind of like HCF, but it's with a bracket. So they both have the brackets. We can take the bracket out, x plus p. What are you left over with in the first term? If you have to block or divide the first term by the bracket. So now the bracket's no longer there. What are you left with? 3x. That's from the first term. And if you do the same with the second term, divide the second term by the bracket, so the bracket's no longer there, you're left with negative 2m. Negative 2m. And now we have factorized fully. Remember always to check inside your brackets to see if we can factorize further, and no, we cannot, because you can't take out any common factors from these two, and this is also factorized fully. So you're done. Right, a lot of my students, when they see 1.1.3, they immediately say, ma'am, that's a trinomial, let's do trinomials, and then they start attempting trinomials. Now, why would they think that that is immediately trinomials? It's not a bad assumption initially to say, let's jump right into trinomials. The reason why they do that is because there's 1, 2, 3 terms, and we know that trinomials, 3 terms. However, and I'm going to say it again, there's a reason this list is created the way that I've created it over here. Highest common factor is number 1 on the list for a reason. We always have to try and see if we can take out a highest common factor first. Okay, so looking at these 3 terms, do they have anything in common that I can take out? Is there any? Okay, so let's start with a variable, because my learners like to start with variables. So we've got p squared and a p, so you might think, oh, I can take out a p, but this term over here does not have a p, so I can't take out a variable. Now let's look at coefficients, big numbers. 2 can go into this term, 2 can go into this term, 2 can go into this term. So we can take out 2 as a highest common factor. So take out 2, then you open your leftover bracket. 2 multiplied by what must give me 2p squared. This must be p squared. Or again, you can ask yourself, what is 2p squared divided by 2? and you're left with p squared. Whichever way makes more sense to you. 2 multiplied by what must give me negative 2p. So that is negative p. And then 2 multiplied by what must give me negative 12. Negative 6. Or, as I've mentioned earlier, you can say, what is negative 12 divided by 2? You get negative 6. Okay. Always just double check that you factorize correctly. Remember how to check. Quickly multiply it back out in your mind. Okay, you don't have to actually do it on paper. You can just quickly double check. Okay, now, are we done? Can we move on? This is another place where my students make this mistake. They think, oh, I took out a highest common factor, I'm done, and then move on to the next question. What's 1.1.4? But it's not finished. You always need to look inside your brackets. So, can I do anything else? Look inside the bracket. What does it look like to you? I've got 3 terms. This one is squared. This one is just p, and this is a constant. Yep, it looks like a trinomial to me, and it is a trinomial. Now, like in my other algebra video, exam video, I said that there's lots of different ways that people teach trinomials, lots of different ways that people do trinomials, and I went over a specific way in that other video. I've done it in videos of mine on this channel. Look at the links in the description box below, and I'm going to be doing it again this way. If you want to do it the way your teacher taught you, of course you are more than welcome to do that. You don't need to follow my method, but it's just that I'm used to teaching it this way, and it works for me and my students that I teach. Okay, so how we do trinomials is always take the constant term, so in this case it's 6 or negative 6, and we find the products. So I know that there's a negative there. I'm going to ignore it for now. I just want you to find the products of 6. So what times what gives me 6? Well, we've got 1 times 6 gives me 6, and we've got 2 times 3 gives me 6. So those are the only 2. We need to choose one of these so that when I add or subtract them, it gives me the middle term. Now look carefully. What is the middle term? Negative p, but remember, technically it's a negative 1p. There's an invisible 1 over there. So we're trying to make negative 1. So when I add or subtract them together, it must give me negative 1. And when I multiply them together, it must give me negative 6. So this is kind of the rule that I use to get my answer. Now I need to choose one of these pairs. Now in no way will 6 and 1 get me negative 1. You can't say 6 plus 1, you can't say 6 minus 1, you can't say negative 6 plus 1. It's not going to work. So 6 and 1, not going to work, not an option. But 2 and 3, if I manipulate those numbers, it can give me negative 1. Now think carefully, this is the way that I do it. If you say 3 minus 2, a lot of my students will get excited and they think that this is the answer. It's not a bad start, but what is 3 minus 2? Because remember I said you must add or subtract them. What is 3 minus 2? 3 minus 2 is 1. Positive 1. Do I want a positive 1? No, I want a negative 1. So it can't be a positive 3 and a negative 2. Then some of my students will say to me, ooh, okay, what if we swap them around? Obviously 3 plus 2 is not going to work. That's going to give me 5. What if we swap it around? What if it's 2 minus 3? Let's think about that. What is 2 minus 3? 2 minus 3 is negative 1. That's correct. So when I add or subtract them, it must give me a negative 1. So positive 2 and a negative 3, that works. And if I multiply them, it must give me negative 6. So positive 2 times negative 3. What's a positive times a negative? Yup, negative 6. So it works. So in my brackets, what I need is a positive 2 and a negative 3. Please don't get it mixed up. Don't swap the signs. It's a positive 2 and it's a negative 3. If you swap the signs, it's going to be wrong, because if you have a positive 3 and a negative 2, that gets you positive 1, and we don't want a positive 1. Okay, so that is how I do trinomials. I hope that has helped you. My next question says simplify. So we were doing factorizing, now it says simplifying, but I want to point out something very, very important with simplifying questions. If you get a question that looks like this, and this is also something that you should have done in grade 9 already, but especially also in grade 10. If you get a question like this and it says simplify, I know what a lot of you want to do. Contrast it to something that is maybe like this. 2x squared divided by 3x. The one on the right is easier to do because you see I've got one term at the top and one term at the bottom. So what you can do is you can say, what's 2 divided by 3? Well, that's 2 over 3. And what is x squared divided by x? Well, that's just x. So simplifying in that case is easy if you've got one term at the top and one term at the bottom. However, in this case, it's not as easy as some people think. What a lot of people want to do, and what I'm going to do now is absolutely terrible, never ever do this, it's wrong. What a lot of my students want to do is they say, well, this x can cancel with this x, and negative 6 divided by negative 3 is 2. And they think that they're done. That is the worst math that you can possibly do. You are not allowed to cancel or divide if you have multiple terms, okay? So do you see I have not one term at the top, I've got 2 terms at the top. I've also got 2 terms at the bottom. What you need to do first, although the question says simplify, what you need to do first in order to simplify is to factorize. Now look at the top. How do we factorize the top? 2x minus 6. Remember, you always start with highest common factor. I can take out a 2. 2 goes into the first term. 2 goes into negative 6. So you take out a 2. You're left with x because 2 times x is 2x. And 2 times negative 3 is negative 6. So I have factorized the top. Now, because I have one term at the top and I cannot factorize the bottom, now I may cancel. You see at the top I've got an x minus 3. At the bottom I've got an x minus 3. Because they are identical, I can cancel them. So please, grade 10s, this is so important. If there's multiple terms, you have to factorize first. So factorizing is very important. Factorizing won't only pop up when the question says factorize. Factorizing can pop up when we simplify as well, which is exactly the case in the next 2 questions. My first question is a little bit more difficult because it involves exponents, but what I want you to see immediately is that we can't go ahead and cancel things out yet. Why? We just learned it, so I hope you can answer that question. Why can't I go ahead and cancel things out just yet? And now it won't even let me erase what I just did. I cannot cancel those out yet. Okay, there we go. Why can't I cancel out yet? I hope that you're saying or screaming at the camera, ma'am, it's because there's 2 terms at the top. And then my next question to you is, so what must I do first? And I hope that you're saying back to me, ma'am, we have to factorize. But now this is weird because we have exponents going on here. One way that really helps my students understand this is to break this up. I hope you know, and I'm going to do it over here, I hope you know an alternative way to write this is like this. 2 to the power of a multiplied by 2 to the power of 1. This is the same thing as this. And just as a reason as to why they're the same, remember, if you take a look at what I broke it down into, are these bases the same? Yes, those bases are the same. And what's the rule with exponents? When I have the same base, I keep the base, and what do I do to the exponents? I add the exponents. Okay, so instead of this thing that I circled over here, instead of this, I can write this as 2a and 2 to the power of 1. This may be helpful for you. If not, it's okay. In the same way that I broke that down into this, let's use highlighter so you can see. Let's use a different color highlighter for this one, just so that we can keep everything nicely together so you can see what I'm doing. In the same way that I broke down that one, I can break down the next one as well. So 2 to the power of a minus 1, let's see if you can break that down. It's 2 to the power of a multiplied by, what do you think? Yeah, 2 to the power of minus 1, exactly. So this is 2 to the power of a multiplied by 2 to the power of minus 1. That minus that initially separated the terms is still there. And then we've got 2a at the bottom. Okay, now, what I've done might seem like I made it more messy, and I get where you're coming from if you think that. But I just want you to stay with me, because maybe if this section was difficult for you before, maybe this method is a little bit more helpful. How many terms do I have at the top of the fraction? Remember, terms are separated by pluses and minuses. So there's the minus separating it. The green thing is one term. The yellow thing is another term. Now, as I said in the beginning of the sum, we need to factorize. How do I factorize the top? We can only factorize the top, not the bottom, because there's only one thing at the bottom. So when we factorize, we must take out something that they both have. What does the green and the yellow both have? I hope you see it. They both have 2 to the power of a. So I take out 2 to the power of a. What am I left over with from the green term? So if I divide the green term by 2 to the power of a, if I get rid of 2 to the power of a, I'm dividing the green term by 2 to the power of a. Basically, 2 to the power of a is gone. What am I left with? 2 to the power of 1. Okay, so we write that there, 2 to the power of 1. And then we do the same thing with the yellow term. If I divide the yellow term by 2 to the power of a, so 2 to the power of a is now gone. What are we left with? Negative, because that negative must still stay there, negative 2 to the power of negative 1. Okay, so how does that look? That looks like this. Negative, that comes from there, 2 to the power of negative 1 divided by 2a. Now, I hope that you are getting excited because what we have at the top of the fraction is one term. What we have at the bottom of the fraction is one term. So now I may cancel. And how does that work? This 2a, because it's identical, can cancel with this 2a. So what am I left over with? I'm going to carry on the sum up here. What am I left over with? I'm left over with 2 to the power of 1 minus 2 to the power of negative 1. And you guys should know that another way to write 2 to the power of negative 1, 2 to the power of 1 is 2, sorry. And then 2 to the power of negative 1 is a half. Check on your calculator if you're not sure. Then we can use our calculator to do the rest for us. So our answer is 3 over 2. If your question says do not use a calculator and show all you're working out, you should know that another way to write 2 is 4 over 2. Okay, so 4 over 2 minus 1 over 2 is 3 over 2. There we go. Okay, 1.2.2, similar thing, simplify the following. And we've got, this is obviously a little bit more complicated for some because you see a fraction divided by a fraction. Now, the first thing that I want to tell you that will actually get you a mark. If you see a fraction divided by a fraction, and this is something that maybe you should have learned in grade 8 or 9 or maybe even 7 already. If you see a fraction divided by a fraction, you must do what we call tip and times, or I also call it KFC. So what I mean is, let's look at KFC. KFC means keep, so you keep the first fraction the same, you flip the second fraction, and you change the divide to a times. Okay, tip and times means the same thing. You tip the second fraction and you change the divide to a times. So the same thing happens over here. How it works is we keep the first fraction the same. So we've got x squared minus x plus 1 divided by x cubed plus 1. So first fraction stays the same. Change the divide to a times and then you flip the second fraction. So we've got 2x plus 2 divided by 2x. Okay, so we do tip and times. Now, in the same way as for the previous question, if you have multiple terms, you have to factorize first. So do you see over here, I have 2 terms, I have to factorize first. Over here, I have 3 terms, I have to factorize first. Over here, I have 2 terms, if possible, I need to factorize first. So what you're going to do now is you're going to look at each little numerator or denominator and factorize. What I tell my students as well is if it's overwhelming to you, block out everything else. So say we want to factorize this top piece, but the rest of the sum is bothering me, literally block it out. So put your hand there, block it out, or what you can do is rewrite it on the side. So x squared minus x plus 1. So we're factorizing this one over here. Block out the rest. Let's factorize it. This is a trinomial. So my factors are 1 times 1. Remember, we want to make the middle term negative 1. Is that possible? No. So if you look at this trinomial, and it's good that we tried, it's always good to try, but if you see this trinomial, you can't actually factorize, because if you look at the 1, you say, okay, it's 1 times 1, but remember the rule is we're trying to make the middle term. So 1 plus 1 gives me 2. That's not the middle term. The middle term is negative 1. 1 minus 1 is 0. Minus 1 is minus 2. Minus 1 plus 1 is 0. It's not going to work. So what I'm trying to tell you is that you cannot factorize this top piece over here. But that's okay. This can't factorize. So we're just going to move on. We're going to move on to the next type of factorizing. Let's see if we can factorize the bottom. And no, you don't need to write can't factorize. It's just for you guys. If you look at the bottom, can I take out a highest common factor? No. It's not difference of two squares because this is not even a minus. I know there's two terms, but that's not even a minus. This is not even a square or even number, so it's not that. It's not trinomial. It's not grouping. It is sum or difference of two cubes. So x3 plus 1. How we do, this is sum of two cubes because plus means sum. How we do sum of two cubes is we open up a bracket, a smaller bracket, and a bigger bracket. Okay. How it works is we do the cube root of that. So just by the way, the cube root of to the power of 3, the cube cancels out with the cube root and we just left with x. Then you do the cube root of 1. What is the cube root of 1? And you can check on your calculator if you're unsure, but the cube root of 1 is 1. Okay, now for the signs, because there must be signs in this bracket. There's a sign here, there's a sign here, and there's a sign here. There must be 3 signs. We've got, this is how I remember the signs, soap. So S means that the first sign is the same. So what I mean by that, first sign is the same. Whatever this sign is over here must be the same over here. So a plus. Okay, so S means same. First sign is the same. The second sign is opposite. So if this is a plus, this must be a minus, opposite. And AP means that your last sign is always positive. Okay, just remember when you're doing sum or difference of two cubes, that you have a smaller bracket, you have a bigger bracket, there's 1, 2, 3 signs in those brackets. The first sign is the same as the question, so a plus. Second sign is the opposite to the question, so a minus. The last sign, always positive. Okay, cool. So let's carry on with factorizing because we haven't finished. So we did the first little bracket. Okay, now how do we get the stuff in the second bracket? What we do is we square the first term. So what is x? This x squared is x squared. We square the last term. So what is 1 squared? It's 1. And then to get the middle term, we multiply these two together. What is x times 1? It is x. So that is how we factorize this over here. I'm going to do it quickly again for those of you that are confused. So remember the top, we can't factorize. So we leave it as x squared minus x plus 1. The bottom we factorize. We said you need a smaller bracket, we need a bigger bracket. The soap tells me about the signs. The first sign is the same. So this is a plus, this must be a plus. The second sign is the opposite. So this was a plus, the opposite sign is a minus. The last sign, always positive. Cube root, x to the power of 3, we get x. Cube root 1, we get 1. Then to get this over here in this fraction, it's this squared. So it's x squared. The last term is this squared. 1 squared is 1. Then you multiply these two together to get the middle term. X times 1 is x. There we go. We factorized the bottom. Now let's see about the other fractions. You can't factorize 2x, so I'm leaving it as 2x. But I can factorize this over here. How do I factorize that? It's 2x plus 2. I've got two terms. What do they have in common? Yep, a 2. So we take 2 out as the highest common factor. We're left with x plus 1. Just check. 2 times x is 2x. 2 times 1 is 2. There we go. So now we've fully factorized. So we've done tip and times. So we have kept the first fraction the same, flipped the second fraction, changed the divide to a times. We factorize each of the numerators and denominators. Now let's see if we can cancel. So how cancelling works is as follows. You can cancel top and bottom, so top to bottom, and you can cancel across the multiplication sign. Okay, so top to bottom and across like that. If they're on the same level, you can't cancel. So this x plus 1 cancels with this x plus 1. Do you see how we're cancelling across the multiplication sign? That's fine. we can also cancel top to bottom. So this 2 can cancel with this 2. Now, there's something else that we can cancel. I don't know if you can see it, but you see here I have x squared minus x plus 1. Here I have x squared minus x plus 1. This is the same as this. So I look like I've cancelled out pretty much everything, but if you look carefully, there is a little x over here that I have not cancelled out. So how you write your answer is as follows. Now, some of my students do it beautifully, and then they go wrong at this point. Draw the fraction line. Look at the top. Is there anything left at the top? No, we cancelled those out. We cancelled those out. So there's nothing left at the top. But you can't leave the top blank. The top must then be 1. Look at the bottom. We cancelled that out. We cancelled the 2 out. But x is left. So your answer is 1 over x. Moving on to some solving. Now remember, when we solve for x, we want to get x alone. Your equation might have 2 solutions if it's a quadratic equation. And please remember to do inverse operations. So let's jump right in. Now, if you take a look at this equation, it might not be obvious to you, but there is an x squared in this equation. And if you see an x squared in the equation, it is a quadratic equation. Your equation will have 2 solutions. We're probably going to have to factorize at some point. And you might say, ma'am, I don't see x squared. Look here. What is x times x? X squared. Okay, so with quadratic equations, what you want to aim for is to get your equation equal to 0. Is it equal to 0 at the moment? No, it's equal to 20. So what I'm going to do in my first step is I'm going to bring this 20 over. It's plus 20. When I bring it over, it's going to be minus 20. Now it's equal to 0. But I've got 2 terms over here. Term over there, term over there. So I need to first distribute, then factorize, and then make it equal to 0 and solve. So what I mean is as follows. If you're lost, hopefully this will make it become clearer. What is x times x? X squared. What is x times negative 1? Negative x. Minus 20 equals 0. Do you now see that I have 3 terms equal to 0? And I hope that this is screaming trinomial at you, because yep, we have to do a trinomial. Remember, I told you, factorizing will not only be in your exam when it says factorizing. You have to factorize when you simplify. You have to factorize when you solve, especially quadratic equations. So how do we do a trinomial? Remember earlier I said the way that I do it is factors of 20 or negative 20. So it's 1 times 20, 2 times 10, 4 times 5. We need to choose one that when I add them or subtract them, it's going to give me the middle term, which again is sneaky negative 1. Which of these, if I add or subtract them, would give me a negative 1? Definitely not that one, definitely not that one. It's this one. But now remember, when I add or subtract them, it must give me negative 1. So 5 minus 4 is not going to work because that gives me positive 1. That doesn't work. What about negative 4? Positive 5. Yes, a negative 4 and a positive 5 will give me, no, that doesn't work either. That's the same thing. Oh my goodness. So let's try it the other way. A negative 5, a positive 4. Okay, negative 5 plus 4 will give me negative 1, which is what we want. And then negative 5 times 4 gives me negative 20, which is what we want. Okay, so in your brackets, it's going to be x minus 5, because we said we want a negative 5, and x plus 4, because we want a positive 4, equals 0. Now, I hope you know that at this stage, when you have 2 brackets, so it's essentially one term, like this, 2 brackets multiplied together, 1 term, and it's equal to 0, we take each bracket and we make it equal to 0. So we go like this. We go x minus 5 equals 0, or x plus 4 equals 0. So here x is 5, or x is minus 4. Remember, the minus 5 comes over, it becomes plus 5. The plus 4 comes over, it becomes minus 4. So we have 2 solutions, which we predicted in the beginning because of the x squared. In 2.1.2, we are once again solving, but we have fractions within our equations. Now, when I do this with my grade 10s, I say if you see your equation contains fractions, so here's a fraction on this side, what you need to do is the following. Make sure that everything is written as a fraction. Okay, so step 1, write everything as a fraction. So what I mean by that is this over here on this side of the equation. It's currently x plus 1. We can write this as a fraction by putting these two terms over 1. Yes, some of my students ask me if they can put x over 1 individually and 1 over 1 individually. You can absolutely do that as well. I'm just going to put the entire thing over 1 like that. Okay, so write everything as a fraction. Then step 2 is to find the lowest common denominator for the fractions. So take a look at the denominator here. It's 2. The denominator over here is 1. What is the LCD? What is the smallest number or the lowest number that 2 and 1 can divide into without a remainder? And you're going to tell me 2. So once you find the LCD, both fractions need to be written over the LCD. This one is already written over the LCD. So basically you multiply this by 1, you multiply the top by 1, everything stays the same. This one over here, how do you get 1 to become 2? You multiply it by 2. That means that you must multiply the entire top thing by 2. Another way to write it is to write it like that. Okay, you're not only multiplying the x by 2, you're multiplying the 1 by 2 as well. Once we have the LCD, once both fractions or all fractions are written over the LCD, we can do what I call dropping the LCD. And please note, we can only drop the LCD when there's an equal sign here and we are solving. So what I mean by dropping the LCD is it's the same there, it's the same there, so we drop it. So we got 3x minus 2 on this side and 2x plus 1 on this side. And sometimes my students ask me very brilliant question or I explain it to them. It's good to understand why you're doing things. Why can we just drop it? Basically with equations is what I do on the one side, I have to do on the other side. And if I want to get rid of a divide by 2, which is what's going on here, I must times by 2. If I times by 2 on this side, I have to times by 2 on this side. If I times by 2 on this side, those 2's cancel. If I times by 2 on this side, these 2's cancel. So effectively, we're getting rid of the denominators. That is essentially what we're doing from this step to the next. Okay, drop the LCDs. Then you distribute and solve like normal. So what I mean by that is 3x minus 2 gets carried down. This is 2 times x, which is 2x. 2 times 1, which is 2. Now get the x's to one side. So the 3x stays here. It's going to stay 3x. This is a positive 2x. The opposite of plus 2 is minus 2 when it comes over. This plus 2 is staying on the side, so it's staying positive. This negative 2 is going over, so it's becoming plus 2. 3x minus 2x is 1x. 2 plus 2 is 4. There we go. That is our answer. Our next question, 2.2, is involving an inequality. So we know we're dealing with inequalities when we see these symbols or these symbols like that. It's an inequality. You apply similar rules to when you do equations, but there's a little bit of extra that you need to know. So it says given negative 4 is smaller than or equal to negative half m, which is smaller than 5. So basically negative a half m occurs between these two values, where m is an element of real numbers. So m is a real number. Solve for m. So 2.1.1 wants me to solve the inequality. So how we do this is we basically do this like an equation. Now this is confusing to a lot of my students, but basically m is my variable. I want to get m alone. Okay? Whatever is next to the m or attached to the m, we have to get rid of. So in this case, this is negative a half. And if you take a very careful look at how this relates to the m, it is negative a half times m. So it's being multiplied. We are multiplying negative a half by m. When I want to get rid of negative a half, I need to do inverse operations because like I said, we're solving. And when we solve, we do inverse operations. So what's the opposite of multiplying? Yes, dividing. So we need to divide by negative a half. But because this is an inequality, we need to divide this side by negative a half, this side by negative a half, and this side by negative a half. We need to do it to all the three places. So if I divide this middle piece over here by negative a half, so it's multiplied by negative a half, we're going to now divide it by negative a half. We will be getting rid of that negative a half by the m. We will just be left with m, okay, in the middle. Because opposite of times negative half is a divide by negative half. So the negative halves cancel. Then, if we divide the left side by negative a half, what we get is the following. We get a positive 8. And it makes sense that it's a positive because a negative divided by negative is a positive. 4 divided by a half is 8. Then we do the same thing on this side. 5 divided by negative a half. And I get negative 10. Now, this is a rule when it comes to inequalities, the most important rule. When you divide by negative, you have to flip the inequality sign. So, if the inequality sign was like that, so it was going this way, when you divide by negative, it must flip around. This one was going this way. When you divide by negative, it must flip around. So here, this one looked like this. When we divided by negative, the mouth is going to face the other way. This one over here, when I divide by negative, the mouth is going to face the other way. Just like that. Another way to do this, if you prefer, is to break the equation up into two pieces. So this is one equation. So we've got negative 4 with the inequality sign like that. And our second equation is this one over here. Some people prefer to break it up. So negative a half m like that. Then you ask yourself, I want to solve the equation. I want to get m by itself. Here I am multiplying by negative a half. So I must divide by negative a half. When I divide by a negative, I flip the inequality sign. M is by itself now because I'm doing inverse operations. And if I divide by negative a half, I'm going to get 8. Okay? Then I do the same thing here. Okay? Well, actually, that's going to end up flipping. This is multiplied by negative a half. To get m by itself, I do inverse operations, which is divide by negative a half. When I divide by negative, this inequality sign must flip, and I'm going to get negative 10. So whatever you prefer to do is fine. 2.2.2 wants us to write the answer to question 2.2.1 in interval notation. Now remember, interval notation is when you use brackets. When you use round brackets, it means not including. When you use square brackets, it means including. And how I summarize it for my grade 10s is if we're going to use these symbols, that is smaller than or equal to. That's bigger than or equal to. Note how I keep saying and equal to. So when we have these symbols with the and equal to parts, we will use the including brackets. Because including means and equal to. If we just have these symbols, we will use the round brackets, not including. I hope that makes sense. So that is kind of how I summarize it for my students. And as you should also know, in set builder notation, the filled in dot means including, like that. And then the open dot means excluding. So going back to my answer over here, basically what this answer means is m is bigger than negative 10, but m is smaller than or equal to 8. A better way to write this would be to put the negative on the left-hand side and the 8 on the right-hand side, although you don't have to, but it does make more sense, and it would end up looking like this. This would be a better way to write what you see above here. It is just better to put the smaller number on the left, think of a number line, and the bigger number on the right. So what this means is m is a real number that is between basically negative 10, but not including negative 10, because you see that there's no equal to sign here, but smaller than 8, but it includes 8. Okay, so how would you write that in interval notation? Which is what they want in 2.2.2. So I'm going to write it over here in 2.2.2. So we start at negative 10, we end at 8. Are we including negative 10? No, so we use round brackets. How do we know we're not including? Because there's no equal to sign over here. It's just m must be bigger than. We go from negative 10, we end at 8. Do we include 8? Yes, because this sign means smaller than or equal to. So you need to use square brackets. 2.3. First of all, 2.3.1 is supposed to be a question that makes you think a little bit. In 2.3.2, we're going to solve simultaneously. But let's ignore the simultaneous for now. We're going to do 2.3.1. Calculate the value of 2x plus y. Now let's read the question. They say 4x squared minus y squared is equal to 171. That's one equation. And 2x minus y is equal to 9. Now, they do not want the value of 2x minus y. They want the value of 2x plus y. So you might be thinking, oh my goodness, where do I get that from? Well, clearly it has nothing to do with this equation. 2x minus y is 9. So we need to take a look at this equation and think about, can I do something to that equation that will help me in this question? Now, if you stare at the left-hand side of this equation, look at this side of the equation, do you not see something that looks a bit suspicious? When I look at it, immediately what jumps out to me is the fact that I can factorize it. You must never ever forget about factorizing. I can factorize it. And how would I factorize it? Remember, we must always try highest common factor, but in this case, I can't take out a 4, I can't take out x or y, so it's not that. Let's try dots. Difference of two squares. Why would I try dots? Difference of two squares works if you have two terms, which I do. If there's a minus between the terms, which there is, square numbers, that's where the s comes from, difference of two squares, 4 is a square number, and the other rule is that there must be even exponents. 2 is an even number, 2 is an even number, so we can do dots. When we do dots, we have two brackets, plus in the one, minus in the other. Then what we do, how we fill in these brackets, is we look at the first term and we square it. Square root it. What's the square root of 4? 2. Okay, so 2 goes there, 2 goes there. What's the square root of x squared? X. What is the square root of y squared? Y and y. I hope you're starting to see something. I carry down the 171. Remember, the question wants to know what is the value of 2x plus y. We want to know what this is equal to. What is that equal to? What we also know from the question is the fact that 2x minus y is 9. So in the place of this, 2x minus y, I can put 9. Like this, in the place of 2x minus y, substitute a 9. I hope you see where I'm going with this. How do I get this term by itself? It's being multiplied by 9. What's the opposite of multiply by 9? Divide by 9. So you say 171 divided by 9, and I get 19. So 2x plus y is equal to 19. Now you might be thinking, where on earth do I get the marks for this? It's only 2 marks, so you get a mark for realizing that you must factorize and then for finding out the answer. It's supposed to be like a level 4 question, make you think a little bit out of the box. Right, now let's solve simultaneously for x and y. So based on the previous question, we manipulated this equation, we factorized it, we used some information that we already knew, and we worked out that we could change this equation to look like this essentially. 2x plus y is 19. The other equation, this one, was 2x minus y equals 9. That's why this question follows on the previous one, because we need to use what we just did in the previous one in order to answer this question. Now, there's 2 ways to solve this simultaneously, and I will go through both of them. The one way is by using elimination. So, how we use elimination is we make sure that we have one variable that is a positive, one variable that is a negative, and when we add the equations together, they cancel out. So what I mean is, if I have a plus y in the one equation and a minus y in the other equation, and I add these two equations together, what is plus y plus minus y? It's basically y minus y, which is 0 y's. So in this case, elimination works perfectly, because can you see here I have a plus y, and over here I have a minus y. So if I call this equation number 1 and this equation number 2, and I say we're going to add equation number 1 and equation number 2, look what happens. 2x plus y equals 19. We're going to add it to 2x minus y equals 9. Look what happens when we add the equations. Make sure the equal signs are lined up. What is 19 plus 9? It is 28. What is 2x plus 2x? It is 4x. And what is y plus minus y? Basically y plus minus y. That's basically y minus y, which is 0 y's. So all I have left is x. 4x is equal to 28. So x is equal to 28 divided by 4. So x is 7. Right, we found one of our variables, x. Now, please don't forget, a lot of students, when they're doing simultaneous, it's quite sad because they find one of the variables and they get so happy that they've done it, they move on with their life. But we need to solve for the other variable, solve for y. And how do we do that? We sub x is equal to 7 into either of the equations. I'm going to put it in number 1. So in number 1, 2x plus y equals 19. In the place of x, we put 7 plus y equals 19. 2 times 7 is 14. So it's basically y equals 19 minus 14. So y is 5. This is how you solve using elimination. I'm going to now quickly show you how to solve using substitution, which for a lot of learners is a preferred method. So starting at the beginning with our two equations, if I want to solve simultaneously using substitution, what I have to do is I need to choose one of the equations and make one of the variables the subject of the formula, which means we need to get it alone. It's often good to avoid like getting a variable alone that will end up being a negative variable, because then you have to multiply it to get it to become positive. It's also good to avoid fractions. So what I'm going to do is I want this positive y to become the subject of my formula. So what I do is I leave the y on the side of the equation. I need to take the 2x over. It was plus 2x. It's going to become minus 2x. This is now my new version of equation number 1. This is equation number 2. Okay, we can ignore the old version of equation number 1. Now, what you need to recognize, and this is where a lot of students don't understand, is that this equation is telling me that y is equal to 19 minus 2x. So in the other equation, everywhere where you see a y, you must substitute 19 minus 2x in that place of y. So what we're going to do is we're basically substituting equation 1 into equation 2. So what I'm going to do is I'm going to rewrite equation 2 here for you. But in the place of y, I'm putting this. And remember, when you substitute, you must use brackets. So carry the negative down. Then in the place of y, I put 19 minus 2x. I'm going to run out of space here. 19 minus 2x, close the brackets, equals 9. Now you just solve like normal. What you need to do is distribute the negative into the brackets. So it's negative 19, positive 2x equals 9. On this side of the equation, I've got 2x plus 2x is 4x. On the other side of the equation, I've got 9 plus 19. Remember, the 19 comes over, equals 28. X equals 28 divided by 4. X is equal to 7, which is exactly what we got when we did the other method. Okay, so x is equal to 7. Then you must still remember to go ahead and find y. So to get y, sub x is equal to 7 into number 1. It doesn't matter which one you sub it into. I'm going to sub it into number 1 because it's easier. 19 minus 2x. 19 minus 2 times 7. That's 19 minus 14, which is 5. Y is equal to 5. I really hope that this algebra paper has been useful. Please go check out the links in my description box below for more past paper videos, more maths practice videos, and I can't wait to see you in more in the future. Please subscribe for more videos like this. Bye everyone.